All right, folks, this is Shetz, and today this lesson's on similarity. Similar figures, they need to have the same shape, but not necessarily the same size. All right, not necessarily the same size. The symbol for similarity is this little squiggly line like that. So, in similar polygons, corresponding angles must be congruent, and the corresponding sides must be in the same proportion. They must be proportional. Give you an example. Here we have a single hash mark, double hash mark, right angle, and right angle. So we know that the corresponding angles are going to be congruent. And let's look at our sides, 3, 4, 5. So if I set this up, the sides are going to be in proportional. I'm going to write an extended proportion here. I'm going to start with a little triangle, a 3, a 4, and a 5. And let me redo that one there. I'm going to put that over the big triangle, which in order would be 6, 8, and 10. 6, 8, and 10. And we're going to see if these are actually equal. What I did was I put the small triangle on top from largest to smallest, and then the big triangle on the bottom in the denominator. And if you notice, the ratio of these corresponding sides, so from above right here, every one of these sides reduces to 1 to 2. Therefore, this is 1, this is 2. 1 to 2 ratio. Small to big. Small to big would be 1 to 2. That is known as your scale factor. All right, all good? All right, let me scroll down a little bit. So we have to determine similarity. We have to make sure that the angles are congruent right there. Right there, the angles must be congruent, and all sides must be in the same proportion. We just did that example of 1 to 2. So let's look at this right here. Here we have congruent sides and double hash marks. So these are both rhombuses. Notice that the sides are all the same. So if I did small to big, that would be 3 over the big piece would be 4.5. Now, remember what I said? I'm going to double everything here because we don't want a decimal and a fraction. We get 6 over 9. When I take out a 3, I'm going to get a 2 to 3 scale factor. So that is the scale factor, little to big. This would be a 2 to 3. 2 to 3, little to big. If I said big to little, it would be 3 to 2. So let's look at our next example here. Let me scroll down a little further. There we go. Well, I noticed right away, here we have a rectangle, but on this problem here, we have a trapezoid. Not all the angles are congruent, therefore, this is an immediate no. Okay, now I look at this here. Well, I got 2 right angles, that's good. We need to see if these, we have no idea what that angle there is or that angle. So right away, I can immediately say not similar. All right, there you go. I'm not even going to bother to check the sides. All right, and I can see these sides are not in proportion. If I change color here, there's a 3 to 3. That's a 1 to 1 ratio. But notice the top and that top. That's not in a 1 to 1 ratio, so I know right away they are not similar. Again, we have to have 2 conditions here. Angles must be congruent, and the sides must be in the same proportion. All right, let's go to the next page. Here, let me scroll down a little bit. Here we have equilateral triangle. Okay, well, equilateral triangle, all sides are the same. Guess what? All the angles are going to be 60 degrees here. 60, 60, 60. And side length is 6. Okay, now we got this other triangle, and it's bigger. It's actually 15. And guess what? This equilateral triangle is all 60, 60, 60. So look what we have. Small to big, 6 over 15. When I take out a 3, I'm going to get a 2 to 5 ratio. So small triangle is small. 2, the scale factor to the big is a 2 to 5 ratio. Great. Okay, here we have a square. Well, a square, we know all sides are the same with length 4, and then a rectangle. Well, guess what? Width of 8 and a length of 8.5. Well, they all do have right angles. That meets one condition, but guess what? Every side is not in the same proportion. So here's a 4 to 8, 1/2. 4 to 8.5, no way, sorry, not similar. And there's that symbol for similarity. Okay, we go to number 9. We have a triangle with lengths 3, 4, 5. All right, I'll just draw that. First triangle, 3, 4, and 5. 3, 4, and 5. Next triangle. Here we have an 18, a 19, and a 20. Well, let's go small to big, just like we set it up before. Small triangle, 3, 4, 5, and I'm doing an extended proportion. And now the big triangle. 18, 19, and 20. Notice this reduces to a 1/6. This doesn't reduce, and this reduces to a 1/4. Are these two similar? No, they are not similar because the sides do not reduce to the same number like in our other problem of a 1/2. Okay, here we have a rhombus. Let's draw a rhombus here. And side length of 8, so they're all 8, 8, 8, 8, great. And angles of 50 and 130. So this will be 50 here and 130 there. The other two angles are the same. Now we have another rhombus. I'll make this one a little bit bigger. And it has lengths of 13, 13, 13, and 13. And it also has consecutive angles of 50 and 130. Great, that's going to be 130, and that's going to be 50. So these two would be similar. Looks like it's a small to big, 8 to 13, 8 to 13 scale factor. Can't reduce that. All right, let's look down here. Scale drawings. Here's just an example right here. Scale drawings, all the angles are congruent. Scale drawing compares the length of the scale to the real length. Okay, most often scale drawings will involve 2 different units of measurement. 1 centimeter is 50 meters. Here's our horse. Our horse, 1, let's call it millimeter, would be 10 millimeters. This is the scale drawing, scale to real life, 1 to 10. Over here, this is kind of hard to read, but you'll have blueprints. Anytime you build a house or even a shed, you're going to have blueprints. All right, let's come down here to North Carolina. Notice the scale drawing. 1 centimeter is 75 kilometers. So we're starting at 0. Looks like we're going to 11. So if we have 11 centimeters on the scale drawing, we're going to times that by 75 kilometers. And notice we're going to end up with 825 kilometers is what real life North Carolina is on the width right here. And in our scale drawing, we have 11. So 11 centimeters on the scale, 825 kilometers in real life. So there you go, folks. You're going to be doing this homework at the bottom of the page. Let me just scroll that down once more. There you go. This is going to be your homework right here. And I believe I'm getting rid of 43 through 47. But make sure you choose one from those exercises. All right, take care. Have a great day.